Hey all, here my champions, me Abhinav Negi and here's I welcome you all in this Brahmastra series where we will be covering each and every subject for civil and mechanical. Whether it is SOM today, FM, irrigation, thermodynamics, storm, HMT, production, each and every subject of civil and mechanical we'll be doing here. And guys, what is the special about this series? That we are not taking any random questions of PYQ of GATE or anything. We are taking those questions that are expected in the Barc format. That is 100 question and 300 marks in a duration of 2 hours. Okay, so we will be only taking those questions that are expected, the difficulty level is expected in the Barc examination for each and every subject. Okay, so today me and Dheeraj sir both will be taking 30 questions that will be covering each and every chapter of strength of material, whether it is deflection, strain energy, whether it is bending stresses, shear stresses, Mohs circle, each and everything we are covering here, guys. And please share the session so that everybody can join in. And guys, let me tell you, this particular session is helpful for both civil and mechanical. And every day for civil and mechanical, we are having each one session. Okay, and guys, this time no paid course for Barc. Only all classes will be on YouTube on this channel only. Over to the super duper, the man himself, Dheeraj Sardana, sir. Yes, sir.
Thank you, sir. First of all, I would like to say, guys, this is a golden opportunity to all of you. Because, guys, if you see about the Barc, there is no previous year's papers available. So, generally, students are somewhere depending upon the seniors, those who have already given the examination. So, that is the major important thing. And that is why you are in the search of the questions, sir. What kind of questions will be coming in Barc? How we shall prepare? What should be the source? We have told you sources in the first brief session related to the orientation of Barc series. So you can see that, you can feel in other terms that whatever could be our paid course of the Barc, that is going to be live on YouTube, because this time we have planned this thing on YouTube to benefit all the students who are going to appear for the Barc examination. And guys, we will be starting with the questions, and all the questions we have framed as per the requirement for the Barc examination. And we have used our experiences, because we also some days have appeared on the Barc. And after that, whatever the students who got selected based on their feedbacks, all those things we have considered by making these questions, so that you can get a clear feel that yes, you are going to have the similar question in the paper. Like sir have already said, they are the expected question for Barc. One day, one subject we will cover, and at that we are also going to be come with the mock test also. So we will give you a feel of Barc before Barc exam, so that you can be familiar to the conditions and the type of question. Yes, over to you, Abhinav sir.
Okay, so guys, Shriram Meena is asking something. Let me tell you guys, see, many are having many questions. Let me tell you 3-4 answers already, although some questions are there, but let me tell you 3-4 answers from myself, which I think that it will be students' minds doubt. What will be the cutoff for civil and mechanical? Session has been done on that. Okay, it will be around 32 to 33 for both the branches. Now you are saying, Raminas, what will the cutoff for ST category? Let me tell you, for general category, the expected, I'm using the word cutoff. For general category, for engineering service, 238 to 242, EWS will be same, OBC will be 234 to 238, SC will be 200 to 205 ST. Ramina, your question, 175 to 180. So according to your marks, you are going to be selected. Now, some of you might be asked also knowing, sir, that what is the answer key? Where is the answer key of GATE? Okay, let me tell you guys, when we come here, we come with 100% proof. As of now, from 5 p.m. in the evening, they are written that the answer key is released. But the server is so heavy that nobody is able to download it, or there is some technical error. So when the answer key will be coming, we both, for civil and mechanical, we are coming for the questions that can be challenged. Okay, we will be coming on that. Now, this is about me, no need to time waste here, but yes, this is Dheeraj sir. Okay, and इसमें भी सर क्या बच्चों को पता ही है अब क्या करना है इसमें. So guys, Brahmastra series, okay, for civil and mechanical both. For each and every subject, the Brahmastra series is here, where we will be telling you the questions that is up to the Barc level. You can join us on Telegram, either mechanical by Dheeraj sir. Here you can ask your queries regarding to the answer to be challenged, or the cutoff of engineering services or GATE, or you can ask me here in civil by Abhinav sir as well. Now, if I tell you about the format of the Barc examination, that it is a 2-hour examination. Total marks are 300. Engineering mathematics is also included here, and it is 100 into 3. 100 questions of 3 marks. Negative marking is also there, -1/3. And engineering mathematics is also included. If I tell you about the cutoff for mechanical, the cutoff was 134 marks. For mechanical engineering, last time the cutoff was 134 marks out of this. And for civil engineering, the cutoff was 144. So it's not tough, quite achievable. Even if your dream of going to Barc through GATE examination is not fulfilled because your GATE examination is not that much good. So there is one more way to go to the Barc, that is by its own exam. But guys, see, opportunities are not less. But the point is, are you capable of that? Have you increased the threshold limit? Okay, that is important. This is total marks, 300 marks. Civil mechanical cutoff 134 and civil cutoff 144. So the point is, are you capable? Opportunities are not less. So make yourself capable. Those students which are capable of clearing any exam, such as like Barc, they can clear it now also. Okay, but if your GATE kharab hua tha, if your GATE exam doesn't go well due to incapability or due to insufficient, incomplete syllabus or due to lack of concepts, then Barc will also be difficult. So Barc is not something like that. Suddenly you do a 20 days course of Barc, like in YouTube here, you will be clearing here. No. We here as a channel, we strongly recommend that those students who are starting their preparation, the Barc 2023 is not for them. Everybody will be saying, come, we hum kara denge, hum ye kar denge, wo kar denge. Let me tell you the truth here in this channel. We always will be telling you the truth. Those students who are starting the preparation from now, Barc exam, Barc 2023 is not for them. At least 8 months they have to prepare for clearing the exams, whichever coming in their way. Might be GATE 2024 or a PSC in October, November, December, or a PSU is taking their own exam in October, November, December. Might be Bureau of Indian Standards, but not Barc 2023. And those students who are capable, 60, 65, 55, 70% is complete, and they are ready to fight with us for next 20 days. Yes, this series is for you. So, Dheeraj sir, am I right? Anything you want to add? Yes, Surat sir is also here. Okay.
Sir, yes, sir. Actually, so I was also saying, as sir, I already told you about the cutoff of the last year. So dear, if we are talking about Barc and ISRO type of examination, written is not of that importance, whatever we are talking about GATE examination. Why? Because here they just want a student who just qualify the written exam. You can see the cutoff is around 50% only. So within 50% they are taking the candidates and they are then judging with the interviews, because the things scientists need to have actually about the good technical, so that they can check only in the case of interviews. So the same thing is done by ISRO also. So once you are just qualifying the written exam, even from GATE they are sometimes called to the rank of 2000. At that rank you do not get IIT, you do not get ISC at that time. Now okay, the number of seats are go, you can get, but obviously old IIT you will not get, but in Barc you will get the code. There you need to prove yourself in the interviews. Okay, so that is the case. So sir, shall we start?
Yes, sir. So guys, total 30 questions will be doing. 5 Dheeraj sir will be taking, then 5 I will be taking. Okay, 10 questions. Then after that 10 questions Dheeraj sir will be taking, and 10 I will be taking. Keep sharing, guys, and subscribe the channel for more such sessions. Now in the whole screen, Dheeraj sir will be coming, and I will be joining from question number 6. Thank you.
Okay, so guys, now we are starting the questions, and I have tried to take the questions of that level, that type, which are coming in the Barc. So the very first question is from the very first chapter. So assuming Young's modulus to be 160 GPa, modulus of rigidity to be 100 GPa for a material, and this is a strain tensor given to you, and you need to find out the shear stress. Let us say how many of you are able to get that. Guys, you will be thinking, sir, they are easy question, but guys, this is the level which are coming in GATE. Yes, 2 to 4 tricky questions are there, that also I have added in that. Okay, so that you can get that kind of trick also. So that is what is required. So Priyanka, okay, my voice is not coming. My voice is clear. Yes, what would be the answer for this? Yes, Biseti. Priyanka, Sriram, Arun, TPM, Parth. Tell me the answer for this question, guys. So this is the question where a strain tensor is given to you and they are asking you about tau xy. They are asking you about the shear stresses. Yes, yes, yes. Setupati, very good. Setupati have answered it. See, what about others? I am checking your comments, guys. Yes, yes, yes. Okay, okay. I'm working on that. Maybe some internet connection may not be that good. Maybe that is the reason. Okay, Aditya, बहुत बढ़िया. Pratyush, very good. So, guys, almost every one of you is saying the answer to be C. So, I would like to tell you that tau xy is given as g times of gamma xy. But my dear, whenever we see the strain tensor, here we are writing it as epsilon xx gamma xy by 2 and gamma x z by 2. Why we are writing this? X phase, y phase, z phase, x direction, y direction, and z direction. So guys, here we will be having gamma yx by 2 epsilon y, then gamma yz by 2. So they are asking us to find out tau xy, for which I require gamma xy, and this is gamma xy by 2. So if this is gamma xy by 2, I need to multiply it with 2. Then I will be saying G is 100 GPa, 100 into 10 power 3 into 0.008. You will be getting the answer to be 800 MPa. This type of question have been there in Barc examination. That's why I have taken this. Moving to the next question, guys. This is slightly tricky question from the torsion. And you won't believe there are some questions which are repeating also from the gate in the Barc examination. At least 4 to 5 questions every year are same as that of the gate question. I'm not saying to mug up the answer of gate question, but yes, if you have practiced them, you will get a benefit of at least 10 to 15 marks over the other students. So let us see how many of you are able to solve this question. Yes. Okay, okay. I'm trying to resolve the sound issue. Let me okay, guys. So give me the answer for this question.
Sir, sound is good. I'm checking it. It's fine.
Okay, okay, okay. So guys, I think sound is fine from my side. As sir is saying, maybe the disturbances are from your side in that case. So tell me the answer for this question, guys. Here you need to find out. You need to find out the rotation Q1. They are saying that this is a shaft in series problem. You can consider this to be shaft number 1, this to be shaft number 2, this to be shaft number 3. It is fixed at both the ends. First of all, you need to find out the support reaction. Then only you can find out the value of theta 1. Just try to solve it, guys. Let us see how many of you give the right answer. Okay, fine, fine, fine. Pratyush have said B. Okay. So some are saying A, some are saying B. I am waiting for other answers as well. Some are saying B, some are saying A. Yes, tell me what is the right answer for this, guys. Wonderful. Mitesh is saying B now. Okay, 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 okay. Aditya is also saying B. Srikanth, B. Mitesh, okay, B. So guys, majority of you are saying the answer to be B. So I would like to say, first of all, we will be finding out the support reaction. You can see this is the case of symmetry. Okay. So because of symmetry, if you see both these 1 and 3rd are same, second one is coming in between, and these torques are also equal. So based on the symmetry, I can say the support reaction at TC and TD are going to be equal. So I can say TC is going to be equals to TD, and that is going to be equals to T only. Okay, direction will be like that because they are subjecting in the same direction. So when this is T, you know, if I want to find out the theta 1 can be written as T1 L1 by G1 J1. They have already mentioned that for AB, the rigidity is GJ1 and GJ2. For this it is GJ1, for this it is GJ2, for this it is GJ1. So I would be saying that torque T1 if I find out by the method of section. So if I will be taking a section here, to the left hand side, the torque is going to be T. So my dear, theta 1 will be coming out to be TL by GJ. By looking at this figure, generally student feels that answer should be A or D because they feel how that much easy answer can be. But guys, that is the trick of this question. Because whenever you are correct conceptually, then definitely, my dear, your answer is correct. So have that kind of confidence in the exam also. If you are doing conceptually correct, it is going to be correct only. So it is not like the आसान कैसे हो गया, आसान भी आता है, tricky भी आता है, मुश्किल भी आता है. Every type of questions are coming. So moving to the next question. So guys, wonderful, you guys have given the answer correctly. Now this is from SFDBMD. We have taken the question from all the topics. Yes, Shekhar, TPM, Shruti, very good. So guys, now answer this question. This is the third question, and after fifth question, Abhinav sir would be joining for the other questions. Yes, do like and share the session, guys. These are top 30 questions I'm saying, guys, and this is my intuition says that you will get 3 to 4 questions directly from the sessions, and you will say, sir, maza aa gaya. So just for that purpose, that is also going to help you. Vijay is saying C is the answer. Parth is saying B is the answer. Okay, what about others? Very good, Parth. Very good, Shekhar. What do you feel? Shruti, Mitesh. What do you feel? Aditya, SK, TPM. What is the answer for this? I'm waiting for your answers, guys. I'm waiting for your answers. Pratyush is saying B. Mitesh is saying B. Yes. What about others? What about others? Great, great, great. Very good. So guys, now let us see. If you see this question, they are saying consider the simply supported beam AB subjected to the point load of equal magnitude as shown in the figure, and they are saying which of the following statement is correct. The portion CD is. So my dear, to see this, first of all, I am taking this beam here with a support reaction like this, and these are two loads like this. So if you see this beam, my dear, first of all, this reaction is RA, this reaction is RB, and this load is W and W. By symmetry, my dear, you know one thing. By symmetry, my dear, you know one thing, that RA will be equal to W and RB will be equal to W, because these distances are given as L by 3, L by 3, and L by 3. So my dear, when you will be making the shear force diagram, you will be getting jump at 4 places. You can see. First jump will be here, second here, third here, fourth here. So if so much jumps are coming out to be, then you know that throughout the CD they are asking that what will be the condition. Is it going to be the pure bending, pure shear, having maximum bending moment, having maximum shear force? So my dear, whenever you are going to make the SFD for this, what kind of SFD you will be getting? So you will be getting, first of all, it is a jump of W, then jump of W, jump of W. This is going to be the SFD. So in this case, there is zero shear force. So definitely pure shear cannot be the correct. Okay, maximum shear cannot be the correct thing. And now when you will be making the bending moment diagram, you know bending moment is 1 degree more. So here you will be getting the inclined line, here you will be getting the inclined line, and here you will be getting the constant. So guys, here you can see bending moment is constant in this region. So the answer for this is A. And don't worry, in Barc, MSQs are not coming. All questions are of MCQ type. So I feel all of you have given the right answer. No, all of you have not given. Some of you have given the answer as B also. There, that is wrong. A is the right answer for that. Moving to the next question, guys. Question number 4. This is once again from SFDBMD part, where they are asking you about the support reaction. This is the point A, this is point B, and I feel they are asking you the support reaction RB. Okay, what they are asking, the reaction at the fixed end of the following. Okay, there may be a horizontal reaction, there may be a moment reaction. So you need to tell what is RB, what is FB. Yes, options are there in front of you. UBL is given to you for 1 meter, 100 Newton per meter. Try to solve it, guys. Abhinav sir would be coming from question number 6. Okay, here answers are coming already. Wonderful. Regan is saying C, Biseti is saying C, TPM is saying, okay, wonderful, guys. What about others? Bhavya is saying B for 4th. Okay, for 3rd, you were saying, okay, fine. I feel, Bhavya, now your doubt is clear. Parth is saying B. Yes. Biseti, TPM, tell me the answer. Yes, yes, yes. Tell me, guys. Pratyush is also saying B. Yes, waiting for others to answer. So, guys, if you see this, a UVL is given. Okay. You know, this vertical reaction will be covering all the vertical loads, means the area of triangle. So, I can write RB equals to the area of triangle. What is area of triangle? 1 by 2 into 100 into 1. So, answer is going to be 50. So, this is a 50 Newton. So, there is a vertical force of 50 Newton is fine, but there should be a moment also. To find out the moment, we will assume this 50 Newton force at centroid of this triangle. And given it will be 1 by 3 meters from here. So this is going to be 2 by 3. And this 1 plus 2 by 3 is 5 by 3. So when you will see the total bending moment for this is going to be the area of triangle acting at a distance of 5 by 3. So you will be having 250 by 3 Newton meter. So guys, force will be there, moment will be there. So when both are there, the answer is going to be B for this. So answer B is correct for all of you, those who have given the B. This type of questions are very, very frequent in the Barc exam. Moving to the next question. After this question, Abhinav sir would be joining from question number 6. What about this, guys? A 0.2 mm thick tape goes over a frictionless pulley of 25 mm diameter. They have given you the Young's modulus 100 GPa. They're asking you the maximum stress induced. Yes. Bhavya, I would also like to say one thing. If possible, try to connect. Yes. Manish. The previous question C is also correct now. Maximum bending moment. Okay, Sri, Vishwati, I will take that question again. But right now you need to answer about the maximum stress in this. Actually, that is not MSQ, that was MCQ. Okay. So maximum bending moment was there at that time. That's correct. Okay. Let us see. Fine, fine. Very good TPM. Very good Anuradha. Ankit, बहुत बढ़िया. Bhavya is saying D for this. Raju is saying C for this. Okay. Options are there. 400, 800, 200, 100. I will show you that question again. Don't worry. What about others? Yes, yes, yes. TPM, what would be the answer? Yes. Everyone. Alok is saying the answer to be D. Okay. So guys, I have told you many times that the bending equation is given by M upon I, sigma B upon Y and E by R. If radius of neutral fiber is known to us, we will be using M upon I equals to E upon R. So from here, actually, if you need to find out the bending stress, then sigma B upon Y equals to E upon R. That we need to use. So we need to find out the bending stresses, and even there we need to find out the maximum. It is E into Y max divided by R. Here, my dear, if you see the value of Young's modulus is already mentioned, it was 100 GPa. So when you will be putting this 100 GPa, it is coming out to be 110.3 MP. Then we need to see the Y maximum. So for that, it is given 0.2 mm thick. So into 0.1. Then radius, you can see this diameter is 25 mm. Radius will be 12.5. So when you will be dividing it, you will be getting as 800 MPa. If you see the radius of neutral fiber, it will be coming some more only. We need to add this one, but that will not be affecting the answer. So answer is going to be 800 MPa. D is going to be the right answer for this. This was question number 5. So now Abhinav sir will be coming. But let me tell you about this question when you are asking. So yes, in CD portion, maximum bending moment is also there. Okay. But this is the part which is going to be under pure bending. So yes, definitely. Actually, this question, if it is going to be in gate as MSQ, then both the options will be correct. Okay. So moving further, guys, question number 6. Sir, please.
Okay, bilkul. So guys, let's move now with question number 6. I'll be taking to you question number 6 to 10, and then 10 to 20 Dheeraj sir, then 21 to 30 me. And guys, let me tell you one more thing, that these questions are up to the Barc level only, because the level of Barc will be little less than the gate, and the answer is quite obvious that for in gate examination for one question it is around 3 minutes, 65 question 180 minutes. but here the ratio is quite lesser. So difficulty level will not be that much tough. Let's go to question number 6, guys. Bending moment equation is given as 5x square plus 20x minus 7. Now from here, what they are asking, what is the shear force? Let us see the 4 options. Everybody on the comment section, give me yes or no. Give me answers. Let us see that how many of you are correct. We know that the bending shear force is dm by dx. So it is 10x plus 20. So shear force is 10x plus 20, and shear force at x is equal to 2. When we are putting it 2, it is coming 40 Newton, and shear force when we are putting x is equal to 1. So x is equal to 1 here. This is the equation of shear force. Of course, it is linear. So 10 plus 1, that is 30. Okay, so this is wrong. This is right. Let me check other 2 options also. Load intensity is again differentiation of shear force. It is 10x plus 20. So load intensity is constant. That means it is a UDL. That means it is a UDL. Okay, constant for independent of x. For every x that is 10, that is UDL. Okay, and slope you cannot find. For slope, you have to integrate. Slope, you have to integrate the bending moment and all those equations. And once you differentiate, the other constants are not coming, or the constants are not coming. But when you are integrating, the constants are coming and there is no boundary condition given. No boundary condition given. So slope, we cannot find it. So option will be A. Okay, such questions will be asked in the Barc examination. And guys, nothing to worry, yaar, because out of 300, if I talk about civil, it is cutoff is around 144. And for mechanical last time, out of the 300 marks, the cutoff was 136, not exactly precise, but somewhere like this. It is achievable. You can go easily to the interview level. After that, the toughness will be there, guys. Everybody else, we all are here. So many students. Can you please write down your cities, from which city you are? From which city you are? Yes, TPM, excellent. EI is also not given. From which city you are? Yeah, come on. We are going to 30 questions today. Now, question number 7. What will be the answer? Everybody on the comments of Visakhapatnam, Vizag. Okay, RK Beach, Jamnagar, the city, I guess, of Ravin Jadeja, Ranchi, Dhoni. Again, Visakhapatnam. So, how many students from Visakhapatnam? Yeah? Rishikonda Beach and all that beaches. Mumbai. Mumbai wale padne bhi lage. I guess they are only in modeling. Odisha, Bhubaneswar, Andhra, Rajamundry, Jaipur, BSSR, Ranchi, Telangana. Okay. Junagadh, Allahabad. Okay, I know you, Harun. Shekhar from Jaipur. Let's do this question now. Come on. Ahmedabad, whole India is here. Come on, guys. Keep sharing. Okay. Everyone out of you. Fatafat say. Okay. So guys, here the downward load is coming. So shear force will be falling down. Let us check this. Then a downward UDL. So slope will be like this. Those who have seen the AN method, Abhinav Negi method, that is not my method, but yes, I'm teaching from this name. Okay. Then there is no load, constant upward load of 151. That means a jump of 151 from minus 51 to plus 100. From minus 51 to plus 100, a jump of 151 will be there. Then no load, it will be constant. The downward load 100, so shear force will be falling. So absolutely A option will be correct. See here, why it is wrong? Downward 47, upward, so it will be jumping, not like this. Okay, 47 upward, it will be jumping, not like this. Even the shear force can be like this here also. So if somebody is making this diagram also, so this is also correct. Might be sign convention opposite. So upward load is jumping. But then it is downward load, how it is increasing then? If it is downward load, how it is increasing them? So both will not be satisfying. Okay, let's move to now question number 8. Beautiful question, yaar. Beautiful question. There is a circular cross section subjected to shear force of V, circular cross section, and a torque T, subjected to shear force V and a torque T. This is the torque T. Now, which point will be the maximum shear stress? Beautiful question, yaar. My favorite, guys. Keep sharing and like the video, yaar. More than 50 students are watching this video. Only 36 likes. Come on, guys. Keep liking, everyone. Now, due to shear force, stress is like this, 0 at top and bottom in a parabolic variation. And due to torque T, the shear stress will be 0 at the center because due to this, it is tau is equal to T by IP into R. So R is the distance from the center. So maximum at 1432. Okay, so it is like this. Like this. Okay, and guys, see, this is wrong. This cannot be answered because the shear stress due to this will be 0 here. And 1 and 5, 2 cannot be answered because at 1 and 2, this is 0. So algebraic summation will not be maximum. Guys, 3 and 4 are the points. 3 and 4 are the points. 3 and 4 are the points where shear stress is maximum due to the shear force also. V shear force also, because V shear force maximum shear stress is at the center, at the neutral axis. And 3 and 4 are the points where due to torque also it is maximum. Oh my God. So answer will be 3 and 4. Answer will be 3 and 4. So this will not be answered. This will not be answered. Now either B or either D. Okay. So either this or both. Because 3 and 4, the shear stress due to V is also maximum and due to torque also maximum. But if you see very closely with microscope, at 3 point, the shear stress, at 3 point, the shear stress due to V is downward. At 3 point, the shear stress due to V is downward force, and due to torque it is upward. So they're cancelling each other at 3 point. But at 4 point, both are adding. Shear force, shear stress due to V is also downward. Due to torque also it is downward. Okay, so 4 will be the answer. The torque is like this now. So at 4 point it is downward, at 3 point it is upward. So 3 upward and V downward are cancelling each other. But 4 downward, they're downward, and V also downward, they are adding each other. Yes or no, everybody, please put a heart sign on the comment box if you got this. Please put a heart sign on the comment box if you got this. Please put a heart sign on the comment box if you got this. Yes, come on, come on, come on. Everybody. Yes. Excellent. Excellent. Keep sharing, guys. Keep sharing the video. Let's move to question number 9. I've already done the homework, so the time can be saved. See, aluminum radius is 2.5 mm. Okay, and is bent in a radius of this 2.5 meter. That means aluminum is something like this. Radius is 2 meter, and this wire itself is of a radius 2.5 mm. Wire, this radius is 2.5 mm. This radius. And if the same bending moment is applied, then I've written with yellow color for copper. Copper is a little bit or yellow and orange now. Then for copper, guys, please see here. The radius is 2 meter. Radius we have to find. For copper, radius we have to find. This is 2 mm. And same bending moment is used. So bending moment equation is this. Now apply this for copper and aluminum. E aluminum, I aluminum, R of aluminum is equal to E into I upon R of copper. Now Young's modulus of both are given. Young's modulus of both are given. I for aluminum is given. Pi, it is pi d4 by 64 now. So in terms of R, you can find out IR 4 by 4. Okay, so this is given for aluminum also because radius is given. R is also known, 2 meter. So here I will be known pi into R ki power 4 by 4 because R is known. So only R can be find out. Okay, whatever the answer, I'm not wasting time for you. Have you got this, guys? Everybody on the comment section, guys. Everybody. Okay. Whatever answer you are getting from here. Please share the session, guys, so that maximum students can join this, can enjoy this, can get the benefit of this. Everybody, keep sharing and like the video for more such sessions, guys. Everyone. Okay. Now, moving forward, suppose here we want to find the reactions. So you can take reactions anywhere, wherever you wish. Let me take in these directions. If my answer is coming negative, that means my directions are wrong. So one is summation fx is equal to 0. So left hand side, RA plus RB is equal to right hand side, these two. 13 and 27 is 40.8. Okay. So one equation, two unknown cannot be done. Another is delta net is equal to 0. So delta net is delta AC plus delta CD plus delta DB is equal to 0. Now for delta AC, cut a section here. See from left or right, your choice. I'm seeing from left. So RA going away. So RA into length is known. AE will be anyhow cancelling out. Delta CD, cut a section here. See from left or right, your choice, guys. Seeing from left, RA going away. So plus, from my section seeing RA going away is plus, this 13.6 coming inside. So minus. 13.6 length is known. AE anyhow will be cancelling at the end. Delta DB, cut a section here. See from left or right, your choice. You can see from right also, left also. Let us see from right. So RB coming inside my hand. So minus into length, AE anyhow will be cancelling, is equal to 0. So two equations, two unknown. Two equations, two unknown. Two equations and two unknown. You can find the reactions. I'm not wasting time of yours in calculation. Two equations, two unknown. Everybody can find this. Yes or no on the comment section. Yes or no on the comment section, guys. Everybody keep sharing the video. Yeah, come on. Are you enjoying this session? What more kind of sessions you want? Please let me know. Yes, Dheeraj sir, please. Okay, Dheeraj sir.
Ji sir.
Okay, now Dheeraj sir will be coming in the speech.
So guys, now we will be starting solving question number 11. Okay. So after we then rest question would be taken by Abhinav sir. So total 30 questions we are going to do. This is the 11th question, and this is from shear stress of beams. Okay. So I think everybody would be giving the right answer for this, and they have given that this is the shear stress distribution. It is for I section, T section, general section, or square diagonal in the horizontal or vertical. So guys, let us see how many of you remember this. Yes, Arun, Raju, TPM, Srikant. Yes. Bhavya is saying D, TPM is saying D. Very good. What about others? What about others? Yes. Tell me, guys. Tell me. Yes. So guys, if you see this question, this is from shear stresses in the beams, and the answer for this is going to be D, because when we are going to have a square with diagonal, horizontal and vertical, then the shear stress distribution is coming like this. Okay, and when we are talking about the I section, for that you are aware that when we are talking about the I section, for I section, whenever we are making, when the width is getting changed, we are going to have a variation. This type of things are coming. Okay, so guys, the answer for this is going to be D. That is correct. Okay, so all of you have given the right answer. Moving to question number 12. This is from combined stresses, principal stresses and strain. Let us see how many of you give right answer for this one. Your horizontal beam under bending has a maximum bending stress. So they have given you the sigma B value as 100 MPa. They have given you the shear stress as 20 MPa. And they are saying what is the maximum principal stress. My hint for you is that this is the state of stress given to us, and you need to find out sigma 1, 2, and the formula is sigma xx plus sigma yy by 2. And that kind of calculation you need to do in the Barc exam also. And I think you are very clear on this, that this is going to be the formula used. And if you're talking about this formula, you are aware that sigma yy is given as 0 to you, and sigma xx is nothing but sigma b, and tau xy is going to be tau s. Let us see how many of you give the right answer for this one. I'm waiting for your answers. Okay, for question number 12, some of you have said the answer to be C. TPM have given the answer C. Bhavya is saying C. Alok is saying C. Very good. What about others? So guys, if you see this question, then if you putting this value 100 here, it is 100 plus 0 cut to this is going to be 50 plus minus square root of. The same here is going to be 50 ka square plus tau xy is 20 ka square. So 2500 plus this is going to be C is the right answer. This type of question have also been seen in the Barc many times. So I feel everybody, Aditya, Shekhar, wonderful, Raju, no one have also given the right answer. Moving to the question number 13, guys, now, and this is something whenever the state of stress is given in the form of a matrix. Okay, and I have given you this question with some other intentions also. The state of stress at a point in a body under the plane state of stress is given by this. Find out the maximum shear stress. So here, my dear, let us see how many of you give the right answer for this. Then I will give you a hint for the question if such kind of thing comes in 3D. How to do that? Yes. Anybody? And guys, do like and share the session. Okay, so answers are coming for 13th. Aditya, okay, TPM have said the answer for 13 is C. I'm waiting for others. Yes, this is the stress matrix. I will give you a hint. In 3 dimension, it is given as sigma xx, tau xy, tau xz, tau yx, sigma yy, tau yz, tau zx, tau zy, and sigma zz. Guys, you just need to solve this 3 cross 3 matrix, sorry, 2 cross 2 matrix. So here 2 cross 2 means you need to take that much. So as per the given thing, sigma xx is 60 MPa, sigma yy is 20 MPa. You know tau xy, tau yx are given as 0. In that case, you know sigma xx will become sigma 1, sigma yy will become sigma 2, and it is given as plane stress condition. We need to find out the tau max, and tau max is given by sigma 1 minus sigma 2 by 2. So what is going to be the answer for this, guys? Tell me. Yes, yes, yes. Huh. So guys, answer for this. What will be the answer? Manish is telling A will be the answer. What about others? Hello, Raju, very good. So guys, when you will solve this, 60 is 20, you will be putting it 60 minus 20 by 2, it is going to be 40 by 2. The answer is going to be 40 by 2 is 20. So some of you may be having doubt about, sir, whether it should be in plane or absolute. So I would like to say absolute we will be saying whenever design word is there, theory of failure is mentioned, or we are looking for the maximum stress induced in that particular component or element, then you need to find out about the absolute. Normally, if they give you plane stress condition and they ask you the maximum stress, you need to answer about the in plane one. So the answer for this is going to be 20, I feel so. Is it clear or not? Yes, Biseti, Shekhar, very good. Moving further to the next question, guys. Okay, next question. Question number 14, it is from columns. Okay, a short column of external diameter D and internal diameter small d. I would like to say this question is repeatedly asked in and engineering services examination. Also, it was repeated in Barc for the feedback of the student. Because when we were doing the series 2 years back, then we have done this question and the student told that, so the same question repeated. So many times these kind of questions are repeated. This is already repeated in ISRO, ESC and Barc also already asked once. So maybe again come, solve it and get the answer. Yes, Shekhar, Biseti, tell me what would be the answer for this one. TPM, a short column of external dias, capital D, internal dias, small d carries the eccentric load. W, the greatest eccentricity, which the load can be applied without producing tension. You know, you will be finding out first of all compressive stresses because of force, plus tensile stresses because of bending moment, and you will say that is less than equal to 0 to get eccentricity. Because of force, you will be saying divided by pi by 4 d square minus d square. Then you know bending stress is bending moment is P into E divided by, this is P into E divided by pi by what is the value of, this is sigma B as M upon ZNA. What is going to be ZNA? ZNA is going to be INA by Y. So you can say it is going to be pi by what is 64, 32. You will put it 32 and that is going to be what? dq power 4 minus dq power 4 divided by, okay, this 64, no? 64 and divided by d by 2. So you need to just solve them. This is negative, this is positive, less than equals to 0. You will be getting the value of eccentricity to be less than equals to. That is the thing you need to do. This is a repeated question in ISRO, in engineering services, and once asked in Barc as well. Okay, as per the memory of the student. So guys, what would be the answer? Okay, I got the answer from Shrikant and TPM. What about others? Dear, this is the simple question of the concept of core climate convert. As this is a practice session, so I am assuming that you are aware of the concept. But still, if you feel you are not aware of that concept, you can ask us. Okay. Even I have, me and Avinash sir have told that in the marathon of SOM also, you will be taking a eccentric load, and by taking the eccentric load, you will be finding out the eccentricity from the center of the load. Okay. That is how you will be doing it. Anyone? Yes. This is the effect of the load as axial. This is the effect of bending, and you need to do it less than equals to. Yes, what will be the answer? Raju is also saying the answer to be C. So when you will be solving this, guys, you can see here D4 minus D4. Here D square minus D square. So it is AK4 minus BK4 that can be written as D square minus D square and D square plus D square. From here only you get an idea that this term is going to get cancelled out. Pi cancelled out, PP cancelled out. So the answer here it is D square plus D square will be left out. So that kind of option is possible only either in B or in C. Okay. So here it is in small d. You can see if you are talking about the load into eccentricity, d to power 4. So here d to power square, here also d. So obviously capital D will be coming out. So the answer for this is going to be C. C is the right answer for this. I feel everybody got it. Raju, बहुत ही बढ़िया guys, बहुत ही बढ़िया. Moving to the next question, guys. Next question, let us say this one. The first Euler critical buckling load of a circular column pinned at both ends is 100 Newton. So this is the column buckled at two ends, and you are applying some load P onto this. And this load is given as 100 Newton whenever this first buckling will be happening. And they are saying that material property revealing saying the percentage increase in the buckling load of the column is when the diameter and length are becoming double. So you should be aware that buckling load is given as pi square EI minimum upon L square. P is directly proportional to I minimum upon L square. You can say it is circular column. So for circular column, INA is going to be d to power 4. Directly proportional to d to power 4 and L to power square. So you just need to see which are the things getting double. Diameter is getting double, length is getting double. Now I feel you can answer it. What should be the increase? Okay, already answer are coming from I feel TPM. The way you are answering, the other students also like Arun, all those who are answering, you are having good chances, and other solution motivate from you guys. And they shall also answer, like Raju is also answering. Very good. Yes, Alok is also answering. Very good, guys. Shrikant, what would be the answer? What would be the answer, Shrikant? And Bhavya, where are you? What would be the answer for this question? And guys, after this question, Abhinav sir would be joining. Okay. So tell me, okay, one more question I will take. Then Abhinav sir will be coming. Yes. Okay, Reagan is saying 100%. So my dear, first of all, this is d to power 4 L to power square. When you will be doing it double, it is going to be directly proportional to d to power 4 and 2 to power 2. So P is coming out to be 2 to power 2, means 4 times. If something is becoming 4 times, how many percent? How much percentage? Obviously, if something was 100, now it is becoming 400, then the change is of 300. So guys, we will be saying the answer to be 300. You can also do it like this. Buckling load in second condition minus first condition in first condition into 100. You will be getting it to be 4 PE1 minus PE1 by PE1 into 100. The answer will be 300%. Okay. So guys, okay, this is the last question. Okay, after me, then Abhinav sir will be coming. So this is the question. Consider the following types of stresses: torsional shear, transverse direct shear, and bending stress. The stresses that are produced in the wire of a closed helical spring subjected to an axial load would include. So guys, you already know whenever we show the spring, what are the types of stresses coming into the wire of spring. We are showing the wire like this, if you remember. We have done the derivation also. So what should be the answer for this? This is last question from my side. What would be the answer for this, guys? Very good. TPM is saying B would be the answer. What about others? Here the chances of learning something new is there. Whether it is going to be torsional shear, transverse shear, bending stress. So dear, if you see this case, we are having the spring like this. You are having a force acting here. If you see this cross section, you see the effect of this force. Then this and this will be making a couple like this. So if you see the wire diameter, you will have a direct shear, you will have a torsional shear. Direct why? Because it is parallel to cross section passing through center. This is twisting couple eccentric shear. So both this is torsional shear, this is direct shear. And when wire is made spring, it is already bended also. So that is why whenever you solve it with normal stresses, shear stresses, you need to multiply a curvature factor because of already present bending stresses into that. That is why you multiply it with curvature factor, and curvature factor into direct shear becomes the Bohr factor. So guys, that is why the answer here should be 1, 2, and 3. Bending stress will be there, shear stress will be there, torsional shear will be there. That was the twist in this question. That's why I have taken this. This question was also there once in Barc and once in DRDO. So some questions are repeated. That's why I'm taking in front of you. And they are just with, because every time I am asking from the students, that's why I'm having this collection. So guys, I feel I will be giving this over to Abhinav sir. Abhinav sir, please. So, sir, I feel, now I have to leave from here.
सर ये लास्ट वाला कौन सा क्वेश्चन नंबर है अभी?
Sir, this is question number 16, 17, sir.
17th. This will be 18th, na? May.
Yes, sir. Yours will be 18th. So, guys.
Okay. Okay. So, एक मिनट सर YouTube पे हूँ, YouTube live में. Okay. So, guys, let me tell you that we'll be completing all 30 questions. Okay, and after that, I have certain information also to tell you. I'll tell you after that. Okay, so let's begin with question number 18. Pure bending means this. See, this is the pure bending now, and in this pure bending, M is equal to constant. Okay, and all the so M is equal to pure bending means M is equal to constant. So dm by dx is equal to shear force. So for pure bending, it will be 0. Okay, and all these formulas, sigma by y is equal to m by I is equal to E by R, is applicable only for pure bending. Although in examination we apply it for every case. Although in examination we apply this for every case, but this is applicable only for pure bending. Okay, so shear force is 0. BMD is not linear. Point load does not mean that it will be a constant bending moment. So the perfect answer is D. Let's move to now question number 19. Yes, you guys, you can TPM is saying that's giving the answers absolutely correct. Excellent, guys. Now let's go to this little bit 19 question. Not that much challenging, but yes, might be some of you are seeing this first time. So what is this question? That here, guys, this is the sigma x and tau xy. This is sigma x is 250. Of course, this is sigma x as per Mohr circle. This is shear stress. So this is 250 and this is 150. Okay, and here the value is at 180 degree from here, diametrically opposite end. So here the values are, the sigma is 0 and tau will be, I'm 100% sure it will be 150. Why I'm 100% sure? Because in perpendicular planes the shear stress is same. In perpendicular plane shear stress is same. And if they are 90 degree in real life, they will be at 180 degree in Mohr circle. Okay, so 180 degree point represent actually the perpendicular points, and perpendicular shear stress is equal. And here it is, sigma is equal to 0. Now what we got? We got sigma x is equal to 250. On perpendicular direction, sigma y is equal to 0 and tau xy is equal to 150. This is what we got. Sigma x is 250, sigma y is 0 and tau xy we got as 150. Now what they are asking? The principal stresses. Now it's a question everybody can solve now. So sigma 1 slash, this is not divide, slash. Okay, sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy square. Okay, so this is the question. This is the question, and sigma x, sigma y, tau xy are known. From this, we can find out the value of sigma 1 and sigma 2. Have you got it? Have you got it? Everybody? Everybody, please give me yes or no. Everybody, please give me yes or no. Everybody, please give me yes or no. Understood or not? Understood or not? Let's move to the next question then. Let's move to the next question then. Question number 20. Question number 20. Okay, everybody, before I solve this is very easy. You tell me answers on the comment section. Before I solve this, you tell me, please let me know in the comment section. In the cross section of a rectangular beam, what is the ratio of average shear stress to the maximum shear stress? What is the answer? I want to see the answers here. B. Okay, what about those? 19B. This is 20th. Okay. This is 20th. Okay, many of you give me answers when I ask this as 3 by 2. Like Shrikant is giving. Okay, Raju. Okay. And that is wrong. Okay, although here the students are very intelligent. They are giving the correct answers. Absolutely, Vipin, Shekhar, Regan, and Muhammad Rashid. Excellent, yeah, Vipin. So guys, tau max is equal to 3 by 2 of tau average. Okay. From here, we see the answer is 3 by 2. But what is asking? The average shear stress to the maximum. Tau average by tau maximum is asked. That is 2 by 3. That is 2 by 3. Got it? Got it? Everybody, please let me know. Okay. Now let's move to the question number 21. 21. Now, a 4 meter long beam simply supported at its ends. 4 meter long beam simply supported at its ends. W at the center. Load W at the center. That is 2 meter here and 2 meter here. If the slope at the ends of the beam is 1 degree, then the deflection at the center is asked. If the slope, what is the formula for slope? What is the formula of slope? This theta is 1 degree. Theta is 1 degree. This delta is asked. Delta is asked at the center. Theta is 1 degree. What is the formula of theta? What is the formula of theta? Everybody, what is the formula of theta? Everybody, please. On the comment section, delta is PL cube by 48 EI. Delta is PL cube by 48 EI. What is the value of theta? PL cube by 48 EI is this, na? Theta. Yes, Srikanth, good. What about others? What about others? Others are not ready to give the answer. PL square by 16 EI. So this theta is PL square by 16 EI. But this comes in radian. So radian, 1 degree means 180 degree means pi radian. So 1 degree means pi by 180 radian. So the value of this is pi by 180. And deflection is given by PL cube by 48 EI. So PL square by 16 EI into L by 3. So this value is pi by 180. This value is pi by 180 into L by 3. So L is 4. So 4 by 3. Now 4 into pi upon 3. This is the answer. This is the answer. Of course, you can convert it in mm. By multiplying with 1000, you can convert this value in mm. Have you got it? Whatever C or whatever you are getting. Understood the concept, everyone? Beautiful question, yaar. Beautiful question. Have you all understood this? Let's move to question number 22. Let's move to question number 22. What is happening here? That for the structure shown in the figure of length L, this is length L and EI, and the equivalent stiffness constant of the structure is at location. So M. If I am applying a P load here, and this is going by delta amount, then the stiffness is P by delta. This is asked. This is asked. This is a beauty of a question. This is a beauty of a question. Now, if I make this goes by deflection amount delta, then K is equal to P by delta is asked. Can you find this question? Can you find this question? Please let me know. Everybody. Everybody. Okay. Now, if I draw the free body diagram of this is P load. So from above bottom, the R reaction is coming. From here, the spring is putting it R reaction. Now the spring is like this. So this R will be downward as everything is in equilibrium. So R will be upward. Now the bottom one is this R will be downward on it. This R will be downward on it. And the deflection of spring, that is R by K. K is 3 for this. K is 3 for this. Okay. So the deflection of spring, that is R by K, that R by 3 is actually equal to deflection of this minus deflection of this. If this goes by 5 mm downward and this goes by 2 mm downward, then total change in length is 3 mm. This goes 1 mm downward, this goes 4 mm downward. The deflection of this will be 3. If this goes 10 mm downward, this goes 12 mm downward. The deflection of this will be 2. So this will be deflection of this P minus R L cube by 3 EI minus this R L cube by 3I. This will be the equation. Have you all understood this? Have you all? R will be coming from P by 3 from here. R is equal to P by 3. Now delta is P by K na. Sorry, K is P by delta na. K is equal to P by delta na. Delta of this. This is the delta at the location of M. They're asking at the location of M. At the location of M, that is the deflection. So P divided by delta. P minus P by 3 will be P minus P by 3 will be 2P by 3. 2P by 3 into L cube by 3 EI. Okay, and all the L values, EI values, everything is unit values. 1. So 1, 1, 1, 1, everything is 1. So everything is 1. So it will be P divided by 2P by 9. P, so that will be 4.5. Please tell me, have you got this? Have you got this beautiful question? This was, what was this question? Let me check it. We have promised you to do 30 questions. This was question number 22. This was question number 22. Have you got it? Let's go now to the question number 23. And as already we told that we are doing the questions up to the Barc level. We are doing the questions here up to the Barc level. Okay, excellent. Because it is asking you whether at the location of M. So M पे कितना P लग रहा है और M पे कितना डेल्टा हो रहा है. M पे कितना P लग रहा है और M पे कितना डेल्टा हो रहा है. समझ गए? Okay. So shear stress C, it will be having 3 points. One, it is 0 at the top. Second, it is 0 at the bottom. And the variation is parabolic. 0 at the top and bottom, parabolic. Parabolic. Once the area is more, here area is more, so stress will decrease. Stress will decrease like this. Area is more, stress will decrease. So, okay, and this always the concavity will be always like this. So this is A option. It is not like this. Okay. Let's move to now. This was question number 23. Now, what is the ratio of average shear stress to maximum stress? Rectangular. Tau max, same question. Sorry, this question should not I take. Tau average by tau max 2 by 3. This question I should not take because I have already taken this. Sorry. 25. This question I should not take because I have already taken. My mistake. My apology. My apologies. Everybody, please tell me. Okay, the stress strain curve for an ideal elastoplastic. Guys, this is elasto. It is elastic. Then with the for no increase in stress and strain is happening, this is plastic. This is elastoplastic. Let me tell you other examples because I'm not Rajnikant, the time coach, whatever question I am taking, that will be coming. Okay, this is elastoplastic. If it comes rigid, that means there is no strain. Whatever the stress you apply, there is no strain. It will be like this. Young's model is infinite. If it is fluid, it will be like this. Without any stress, strain is happening. Without any stress, strain is happening. Without any stress, strain is happening. Okay. Now, if it is perfectly plastic, it is elastoplastic. If it is perfectly plastic, like this. Okay. Now, if it is elastoplastic with strain hardening, elastoplastic but with strain hardening, strain is not easy like this. Without an increase in stress, strain is happening. Okay. It is elastoplastic with strain hardening. This is strain hardening region. This is strain hardening. Strain is not easy. We have to apply a little bit stress. So this is elastoplastic with strain hardening. This is only elastoplastic. This is rigid. This is fluid. This is perfectly plastic. Have you got it? Have you got it, guys? Everybody on the comment section, please let me know. Everybody on the comment section. जल्दी बताओ, जल्दी बताओ. Have you got it? Okay. Now this was 25th. Let me go to the 26th question as per Barc level. The strain energy. Okay. So guys, I have many times derived this also. The P delta curve gives the strain energy. I have given the complete derivation and the logic. What is strain energy? What is the physical meaning of strain energy? You can see in my strain energy lectures. Okay, and stress strain graph is strain energy per unit volume. And why I have made linear? Because Hooke's law is valid. Why it is strain energy per unit volume? Complete logic I have given. Now, what is this value? What is the area of triangle? 0.5 y into x, sigma into epsilon. Okay, so point area is 0.5 into stress into strain, that is strain energy per unit volume. They are strain energy, so multiplied by volume. This is option number D. This is option number D. This is option number D. Got it? Okay, now 27th question. Everyone. In a composite system subjected to a temperature rise and with ends constrained to remain together, the component having lower value of alpha, this is composite here, and what is happening here, the two bars are there, 1 and 2, alpha 1, alpha 2. Suppose alpha 1 is greater than alpha 1 is greater and alpha 2 is smaller. That means alpha 1 is greater than alpha 2. Then temperature is increase or decrease, because answer will be reversed in both the cases. Temperature is increased or decreased, please check. Temperature rise. So if nothing is there, 1 will be increasing more and 2 will be increasing less. Both sides I am just seeing only one side. Both sides they will increase, I am just showing you on one side. But now, since it is composite, delta has to be same, so they will be compressing up to here. So this will be constraining itself to here and this will be pulling. So more alpha will be compression and lower alpha will be in tension. Lower alpha will be in tension. Okay, and if temperature was decreased, it will be reversed. Okay, now 28. The component of strain tensor at a point in the plane strain can be obtained by measuring longitudinal strains in the following directions. Guys, if you find the strains in 3 directions along any 3 arbitrary, any 3 might not be perpendicular, then strain tensor, stress tensor, everything you can find out. Okay, 3, you can see my strain rosette video also. Just in 3 directions, if you know the strain, okay, because what is happening, let me tell you. Suppose this is x plane, this is y plane, and this is x dash plane. This theta you know. So suppose you know strains here. So epsilon x dash is equal to epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 cos 2 theta. This is known, this is known, this is known, this is known, theta is known, plus gamma xy sin 2 theta. So all this gamma xy you can find out. Now gamma xy you can find out. So epsilon 1 slash epsilon 2 you can find out. Epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y 2 whole square plus gamma xy by 2 whole square. So this you can find out. So now epsilon 1 and epsilon 2 is find out. So sigma you can find out. Sigma 1 is equal to E upon 1 minus E square upon epsilon 1 plus mu epsilon 2 whatever. So just from 3 things you can find everything. Okay. Now in a biaxial strain, the minimum engineering shear strain is, Let me tell you the Mohr circle for strain now. Mohr circle for strain now. Let me tell you Mohr circle for strain. So this is epsilon. This is gamma by 2. This is epsilon. And this is gamma by 2. And Mohr circle will be like this. Now suppose this is epsilon x and epsilon y. Okay, what is maximum shearing strength? This one. So gamma by 2 max. Gamma by 2 max is the radius. So radius is, this is epsilon x, this is epsilon y. So radius is epsilon x minus epsilon y by 2. So what is gamma max? Epsilon x minus epsilon y. Have you got it, everybody? Okay, 30th question. 30th question. 30th question. It is only 29. Okay, 30th. Okay, 30th. Okay, let's do only 29 questions, guys. This is my Telegram, Civil by Abhinav sir. You can join me. Okay, this is my Telegram, Civil by Abhinav sir. You can join me. And let me tell you one more thing, that there is a workshop. Okay, let me tell you that there is a workshop also. Where is that? (23rd Feb, 7:30 p.m. 23rd Feb, 7:30 p.m. workshop on app. A special workshop by Richa ma'am this time. By Richa Gupta ma'am at 7:30 p.m. and the title is How to Ace GATE 2024. How to Ace GATE 2024 with college or job. This will be 7:30 p.m. on app. Okay, this will be 7:30 p.m. on app. Any more doubt, guys? Please let me know. And let me tell you now what I want to tell you at the end. Why differential is not there in strain? What is differential? Have you enjoyed this? Let me tell you guys, we will be coming with all challenges. Answer key is released. Answer key is released for GATE 2023 for both shifts. Now we will be coming, if I have to see, I cannot say that many are saying that hum challenge karenge. First of all, I have to see the answer key. If there is something that has to be challenged, and if there is something that our whole team will be coming with that. Okay. Thank you. Thank you, everybody. Thank you, guys. And you can join me in my Telegram, Civil by Abhinav sir. Okay, or Mechanical by Dheeraj sir for any more doubt. Thank you. Okay, B. Satish, I'm not getting your question. Please tell me on that, my Telegram, what you want to exactly ask. Thank you all. Take care. Thank you. Thank you, everybody. Thank you all.